to my channel. We are going through this LeetCode problem set, and we are on LeetCode problem number 63, unique path number 2. So I did this a while ago, I think back in August. Yep, back in August. Don't know why I didn't make a video. Also don't know why I did it out of order. But you guys are more than welcome to read this question on your own time, but I'm going to go ahead and jump in with this solution, and I want to show you guys my submission before I forget. So my memory, I didn't do that well. It was 43%, but my runtime was 91. So did well in something, not as well in the other, but you live, laugh, love in whatever condition you're in. So let's go through this kind of brief explanation on what I did here. So basically, the premise of this is like you need to, you're given like a grid with obstacles, right? And you need to find the number of unique paths from the top left, similar to unique paths in question number 62. We have the video up on the GitHub, or not on the GitHub, oh my goodness, the LeetCode playlist in YouTube, and it should be right before this. But you need to find the unique number of paths from the top left to the bottom right corner while avoiding obstacles. In the previous one, there were no obstacles to avoid. You just had to find as many unique paths as you could, and that was it. So we're starting off with M and N, which are, for this sake, rows and columns. And we're just calculating the rows and columns in this, what we are calling obstacle grid. We then have our dynamic programming initialized as a 2D array of the same size for that obstacle grid, filled with zeros initially, and that will be used to store the number of unique paths for each cell. So for example, here we'd have 0, 0, 0, 0, 0, and as you continue to go through these paths, it would tally up accordingly. So we set the DP to 0, 0. The DP00 is set to 1, I'm sorry. So if the top left cell in the obstacle grid is not an obstacle, 0, or otherwise it initializes it as a starting point. And the two loops in here, these for loops, handle the boundary conditions, the for I in range and for j in range. They just check to see if there are any obstacles in the first row and first column and calculate the number of unique paths based on the previous cell's value. The nested loops is where we iterate over the entire grid except for the first row and first column, because we already did that in the two loops prior. So we just calculate the number of unique paths for each cell based on the cells above and to the left, which I think is very important to note, but only if the current cell is not an obstacle. So finally, this DP M-1, N-1 contains the number of unique paths from the top left corner to the bottom right corner, considering the obstacles, and that is the summary of this code. Now, obviously, like I said before, it could have been a little bit better when it came to memory, but other than that, I actually was pretty okay with the solution. It's close enough to 50 where I feel like just one or two tweaks could have really nailed it, but other than that, pretty happy. So I have this in my GitHub repo, which is linked down in the video description down below. You guys are all more than welcome to fork it, clone it, make it better, make it worse, have some fun, learn something new, and I will see you guys in the next video. Thank you so much for watching. Goodbye.